it's all ready for that, come back into the seats, and we're looking forward to having you participate in this next panel. This one is something that is near and dear to my heart as far as next-gen IT. My name is Jody Tyrus. I'm a security architect at a small winery out in California.
Nice.
I'm probably a customer of many of you in the room, and so I really enjoy learning about how your companies are going to help my company take our technology to the next level and help us leverage new things to make our product better, faster, in some cases cheaper, but certainly in the hands of our consumers. So without further ado, let's introduce the panel. And as you introduce yourself, earlier you talked about your first jobs and what you're doing now. So in the spirit of this theme, let's hear about what awesome technology did you originally start off with, and what is really what's lighting your fire now. Just kick it off, Matt.
Awesome, happy to. I'm Matt Brender. I'm a developer advocate at Intel, and I started out working at EMC, working on the FC700 series of fiber channel storage arrays. I was in tech support for that, working on those. And what I do now is more focused on, I guess, the cloud native application. So I'm playing with Kubernetes quite a lot, and I really think a lot of us will end up moving that direction. So playing with the container runtimes and the telemetry frameworks by which you gather statistics from them.
That's awesome. My name is David Klee. I am the founder of Hairflux Technologies. I'm lucky enough to be both a Microsoft MVP and a VMware vExpert, so I can watch what the other thinks of the other, and it's pretty hilarious.
You're the one.
Yep. First job, believe it or not, so middle school. Most folks are doing normal jobs. Well, I was always that nerd that would go ride my bike to people's homes and fix their computers for cash. And kind of evolved all the way up, and now we deal with a whole lot of advanced data systems. Things that are exciting now, very fast storage arrays, and how the bottlenecks in the systems change when storage is no longer the primary bottleneck. In-memory data handling, HADR, a lot of performance tuning. I'm a nerd. So.
You're amongst friends.
Cool. I'm Tim Carr. I'm a solutions architect for a consulting company in Chicago named Ahead. I think Sean Massey was on the previous panel. He's one of my colleagues, great guy. My first job was a trumpet teacher. I'm a musician. I have my master's in trumpet. So naturally, I'm in IT because trumpet doesn't pay the bills. So the things that I find interesting. I mean, I started off as a Linux system administrator, right? And so I'm against Windows. So I think it's funny that you're talking about VMware and Microsoft and stuff. I'm not against Windows. That's a lie. But
server is now on Linux pretty soon. So.
Yeah. No, but I started off in the Linux world, then I kind of moved on to VMware because I saw this thing called virtualization, which was pretty cool at the time. And I moved on in that area, and now I'm kind of moving on towards the containers side of the world and also public cloud. I think that's the next generation of where we're going with everything. So I'm kind of changing focus into that area now.
Cool. I'm Swarna Padilla. My first job was testing engineer, or as we call it now, quality engineering, back in Sun Microsystems when Sun was pretty cool in India. Now I've moved to a much smaller company where we make load balancers cool again.
Hey everybody, I'm Josh Coen. I'm a cloud architect at Sirius Computer Solutions. It's sort of like Ahead, but older, bigger company. Not that it's good, I'm just trying to get some context.
His resume will be up to date by the end of this.
My first job actually, when I was in high school, was a locksmith, actually. I wanted to learn how to pick locks, so naturally I got a job as a locksmith. So.
Good. When we look at new technology, what is the one thing that you see as the most disruptive that's coming? And how do you think, I know that one of the things that I challenge my friends in the tech world, because I come from the customer perspective, is a lot of this is really cool, it's really neat, it sounds great, it's game-changing. What is the next thing that you see that's the most disruptive, and how do you see your customers using it in a way that's going to make a difference for them?
Yeah, that's a great question. I think one of the things we've talked about for a long time is measuring the right things in the data center. Like, how do you get visibility into what you're responsible for? Operations engineers have always had to do this. We do it through whatever GUI we like or whatever CLI command we like. But being able to aggregate that at scale, especially as our runtimes diversify, having virtual machines, bare metal systems, containers, and maybe some serverless functions running side by side. How do you get a dashboard of what's running and what's operating? And that whole aggregate of seeing all that information is the collection, processing, and publishing of that is called telemetry. So I've been playing with telemetry lately, and I think that's really a game changer right now, because if you can see the right information in your infrastructure, you can start to make decisions on them in an algorithmic way, which lends itself to better scheduling and better automation.
I'm all on board with that because I love to be objective about a lot of these things. We deal with a lot of very large data sets, very high demand systems. The thing that really excites me right now is next generation storage technologies. So, persistent memory, all these very, very fast flash arrays and beyond, and watching how people are trying to embrace it with the old mindset of it's faster, plug it in, it just makes everything go. But now we want to watch how the system changes because if storage is no longer the bottleneck, where's the next bottleneck? Is it networking? Is it interconnects? Is it code? Is it the way the data is being stored and queried? And it's fascinating because little things, a 2 millisecond ping can mean a 9 times performance hit to a big database server on an all-flash array. I mean, it's just fascinating.
I think that's really interesting that you talk about performance tuning. I agree with that, but when I take a step back and look at performance tuning, I think about how do I performance tune my organization to deliver services more quickly. And I think a big buzzword out there is cloud, and I think public cloud, while we're starting to consume it as organizations, to be able to divide services into PaaS offerings, to be able to offer, all the public clouds now have container offerings as well. I think that that's still the next generation for a lot of organizations, and understanding how to properly consume those things is going to be the biggest thing that we see enterprises struggle with from a performance tuning of the business perspective.
How do you get over, how do you get over kind of the fear of, your internal IT department where all of a sudden the little silos that they had of power, you had your storage admin, you have your network administrator, you have your security administrator, and we had, under those domains, we knew exactly, and we didn't let the network guy come play in our sandbox, and they didn't let us play in their sandbox. How do you think companies are going to get over that hurdle where either they're going to have to retrain some people to learn those technologies, or they're going to have someone come in and kind of help them lift up for that? Mostly to you. Yeah.
Oh, is that to me?
Yeah.
Okay. All right. Great.
kind of-
Well, I was making sure I wasn't hogging the stage. I don't want to do that. So I think that what we see when we see organizations moving towards cloud is the successful organizations are the ones that take members of each of those teams and really place them on a cloud-centric team for infrastructure and for automation. Those are two areas that everyone has to learn. If you're not programming today, the first step is go pick a language. It can be PowerShell, it can be Python, it can be anything. Just go pick that up now and start doing some coding as part of your career. Take that and work with other members of teams that you're not comfortable working with. My name's Tim and I suck at networking, right? Literally, I've told everybody that in my life. But you'd be surprised what I've learned about networking in the last 2 years because I've been asking people who are really, really smart questions about those sorts of things. And the successful organizations put those people together so people can naturally, through their daily activities, work with one another to advance themselves and ultimately the business.
And I've seen the same thing. You can still have sandboxes, but I think I was going to say when you say the disruptive technology that's coming at us, Pokemon Go was probably the first disruptive technology that's coming at us, but it's already here. But going back to what we said before, I think the machine learning, that's what I kind of surface it up because it's about telemetry, it's about performance, but it's about machine learning, how we can capture all this information from the data that we collect so far, and how can we be more predictive than reactive IT. We want to know before something breaks, or we want to know that something is going to break before it happens so that we can be proactive. So how can we measure all this information that everybody is collecting, every single piece in the infrastructure is collecting, and how can we use that information with kind of more visibility or more intelligence, and how can we use that to make sure that the infrastructure doesn't break, the applications don't go down, like Pokemon Go always goes down. And that usually functions very well if all these different sandbox teams or siloed teams function together or work
Start talking
together.
and communicating.
Exactly.
Yeah.
It just gets easier.
Yeah. How many of you out in the crowd, sorry, I'm a little loud there, have teams like that where there is good collaboration between the different areas of IT? Do you guys find that on there?
Wow,
Yeah.
that's more than I thought.
Yeah.
We were kind of forced to do that at where I work. You move us all in the same building and make us eat lunch next to each other, and eventually we start grumbling and griping, and then you come to find out you really have I don't want to say common foe, but you have a common desire to, number one, keep your job, and then make that job easier. And how are you going to make it easier? So you start tossing ideas off each other. When you talk about pick up a language, PowerShell, and I'm just like, I'm not a coder. I'll never be a coder. And then, my desktop guy is talking, well, if you did this, you could write a script and it would, probably save you, 30 minutes a day doing something. I'm like, okay.
I'm interested.
I am interested. You got my attention. And then, here's a book or something. And so having that and at least being open to learn the new stuff and not be afraid of it, especially in an IT department where it's more traditional. That's the challenge, is not to be afraid of the change.
It's actually how we named our company. Heraflux Technologies. You know that phrase, the only constant is change? It's coined by a Greek philosopher by the name of Heraclitus. We love to be in front of the change. We love to make the change. The education that we've all been talking about is absolutely key, because disruptive new technologies tear down silos. It changes a lot. But the funny thing is, the more it changes it, the more it stays the same. Adapt a few buzzwords, but you got to deal with the processes around it.
I want to talk more about the becoming a developer or coding and demystify that a little bit, though. What I find both really exciting and frustrating is that we're excited about code as part of infrastructure. The frustrating part is that most people I talk to that are in operations, they're like, no, I couldn't possibly do this. And I just want to shake most people, like Nigel up here, and be like, you've been doing it your whole damn life. Look at a bash script, for God's sake.
Yes.
Look at a YAML file. Guess what these are? They're syntax, they're languages. There's nothing special that differentiates YAML from Python, from Go, from Ruby. These are all just ways in which you format logic, and the logic are the things that you actually already know. And maybe I think the thing that gets confusing is what you do with it. Mm-hmm. Instead of just saving it in a folder on your laptop and renaming it between old and new, you actually push it into something called version control, like Git, and then you share it on GitHub. So there's some new kind of platforms and tool sets that you need to coordinate, but think of them as individual pieces of the puzzle and learn them one at a time, and lo and behold, you're a developer, because we all actually do that already.
That is one of the things that we're trying to do, is when we talk about automation, is get rid of the things that are taking up so much of our time so that we can learn the new technology. So all the low-hanging fruit, and we use that term a lot in our industry, get rid of all the things that can be automated or that can be done self-service. And then all of a sudden, as a security architect, if I have 2 more hours a day,
that's huge. What
could I do in 2 hours a day that could help me or help my company, be even better, stronger, and be positioned to do better things? So I didn't want to forget you at the end.
Yeah, no, to answer your original question, for me, the disruptive technology, not really relevant to probably our customers today, is blockchain. So if any of you guys are familiar with Bitcoin, blockchain is the underlying technology that runs that, and a lot of financial services are starting to adopt it. It's something that I think is going to have a very big effect in our personal lives, probably in the next 5 years or so. From a customer perspective, sort of like what Tim was saying, we're seeing a lot of businesses, and no offense to David, they don't care about the gear anymore. I mean, it's important, absolutely, but they don't care. They want to take their business process, their line of business, and they want to know how do they make it more efficient, and what do they need to do to get there, because they're paying the network guy, the VMware guy, the storage guy. They're doing all this, and they're not very efficient at it, and they spend 85% of the time just trying to make sure the building doesn't burn down. So that's sort of what we're seeing.
Like the bottleneck is the process, not necessarily the spindles.
Yeah, absolutely.
Yep.
Yeah. A lot of that it becomes culture change too, is where you have always done something a certain way, and even when you introduce new technology, there are people that are going to drag their feet, or they're going to be the long pole in the tent because they're not comfortable with it, they're not familiar with it, and they like the systems that they like, and even in my case, going from certain platform of Windows or even a certain platform of Red Hat to something else, AIX. It was just kind of like, this is what I know, this is what I'm good at. And so it was kind of, you have to change the culture a little bit into rewarding people who can become agents of change. And some people aren't comfortable with that. But when you do find people that are, then the challenge becomes, how do you seed them in the organization so that it's not just a small little section of people that are doing great and wonderful things while the rest of the organization is just kind of like, yeah, well, innovation labs, they can do what they want, but it's not going to affect us.
I think you hit the point really well. We're rewarded in our organizations in IT today, not so much for how good you are, and I mean, maybe this is wrong in some cases, but not for how good you are at doing that one thing. If you really think back at what got you there, it was you were rewarded because you could learn that thing. So be a learner, pick up the next thing, find the next thing that you're supposed to learn, and move on and do that, right? I think that's what you have to do.
One of the follow-up questions was, about software-defined networking, and that is a good example of kind of the fear in certain departments where you have network guys that their entire lives and they're amazingly strong network people in enterprise systems, and their fear is, we mean the VMware guy is going to set up the network, and they don't even understand networking concepts, and so it's like, well, you can go work with them, and you can help train them, and you can close that gap. How do you guys see things like software-defined networking and containers changing the way that you're doing things at your companies and your customers are doing things?
Sure, yeah, I really like that. It comes down to, where do you package up something? So I think containers as a concept is really interesting because it has to do with packaging dependencies. It has nothing to do with really anything else. It's, you're putting things together, and the person that's defining what those things are is the quote-unquote developer. That person that's writing the code is also saying what they need in the container, and then somebody else who's more operations focused just has to deploy it. They don't have to know what version of Ruby they need and whether they need to install this package from Ubuntu or whatever. And it just makes more sense to have that dependency of the application be packaged up in an artifact that is called a container, as opposed to the entire VM and having to own the operating system down. So when I think about how it's changing things, like I'm a terrible developer, but I write some code with people that are...
You're a great advocate.
But I advocate for them. That's important. But I work with people who are just trying to figure out what their problem they're trying to solve, and they can write the code really quickly. So I end up figuring out what we need to do in order to fix our process as a team, or help other companies fix their process through things that are actually really well defined as containers. The sort of stateless, run many of them or run once and let it go die off type of processes. So it comes down to a conversation and reworking of, what do I think of as an application and who's deploying it, and how can we help each other get to a point where all that stuff just runs on this platform that, it's just different segmentations of layers.
I think the software-defined technology kind of picked up pace because when I look at it, I see it as not just a separation of data plane from control plane, but it's like the airplane analogy. The pilots don't need the entire air traffic control in the airplane. So they rely on the experts sitting in the ADC to tell them when to navigate, how to navigate, when to land, what angle to start decelerating, and all these details. So I think that is perfect for even the IT infrastructure, because what the data plane is doing is independent of control plane, but it kind of leans on the intelligence coming from the control plane, which is why one of the reasons the SDN wave kind of immediately was adopted, because it just makes deployment easier, it simplifies the operations, it automates everything else, and coming from a container or microservices technology as well, it just simplifies the deployment, because now the applications or even the infrastructure is, what infrastructure you're deploying your applications has become independent. Yeah. You can deploy anywhere because now the data can go anywhere. It could be in a VM, could be in a public cloud, could be in Google, Azure, or AWS, or it could be in a container. Regardless of where the data is, the control plane is sitting somewhere else. It collects all the telemetry, again, from all these different entities that are deployed everywhere, and it sends signals that, hey, this particular application is going down, or this particular application is being overloaded, immediately remediate. So software-defined is not just software-defined networking, but just software-defined architecture itself is becoming extremely efficient for IT.
Yeah, we see that orchestration piece of doing that, and so that you're not having to, historically, someone would come to us and say, we need to solve this problem, we need you guys to write a program that does this. And then they'd sigh and they'd stop and they'd whiteboard it and they'd write it from scratch, and it would take a year, and then they would test it and then they would deploy it, and then they were like, okay, we're not going to touch it for another 2 years, and then you'd come with us with all the different changes you want after that, and then the cycle, that was the cycle. I mean, if you guys laugh, but that's how a lot of enterprise companies, that's how we were used to working. And it wasn't fast enough as the company, and as we were looking at things that came in from the outside, as our business side became more tech savvy, and as they started to see stuff in the cloud that like, well, I can just download this, or I can sign up for this service, and it does exactly what I've been telling IT I would like done, and I don't have to worry about that. So we had to get in front of that. And then we realized internally with our developing staff is there's no 2-year cycle now to build it. There's not even a year cycle to build anything. It's a continuous cycle now where you need to hurry up and build something, reuse code, and not write everything from scratch anymore, and then just iteration, 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 and iteration. So that was something that was a little bit of a culture change and a shift. And in some cases, we had to go out and hire new people who were used to working like that versus people that were just kind of very comfortable doing the same thing that they were doing for a long time. Do you guys see a lot of change in your IT departments or in your developers where that's becoming more the norm?
Well, I've got a question if I could. How many people are using open source tools in their IT infrastructure right now? Okay, I'd say over half the room without a doubt. I think that is a sign of a culture change, because if I was going to hire somebody that was working on our infrastructure right now, I would hope that they Google for the best open source tool for something before they say, here's my 3-year roadmap of why we should build a monitoring platform. Like, I hate you, there's already 15 that are fantastic and they're under great licenses. Why don't we contribute back to something that's already doing a really good job of it? So that's a huge culture shift. And when I think about our new agey tech, I think part of the new aginess of it is you can share with other companies. If it's not bringing value to your business, if it's not part of your core competency, it should be open sourced. And we see more and more companies going in that direction, and I'm really proud to be at Intel when we're really helping facilitate open source adoption. Do you see more of that or have thoughts on open source?
I love open source when it's the right use case.
Could you elaborate?
Well, it's like the majority of what we do is dealing with proprietary data platforms. Most people want to use that as the sole source of the truth, the sole repository. But there's tremendous use cases for all these different data platforms out there, cloud, private cloud, you name it. Open source technologies, in-memory data, proprietary data systems. It all depends on what you want to do. Open source should never be discredited. We use a lot of it with everything that we do day to day.
Well, and also depends, I think, on, I'm sure that they're not defined, but there's got to be tiers of open source software, right? Matt and I can go create something that'll tell you when your lights are on in your house. But if you have a 100,000 square foot building complex, you're probably not going to make sure your electricity bill stays down with what Matt and I dreamed up over a beer or something like that. So I think that it depends. There's levels of when you put your core competency or your what you rely on for revenue on an open source platform versus something that's not. And a lot of people look at Red Hat. They've done a great job of taking open source platforms and making them into an enterprise supported platform. So out of those folks that raise their hand about open source, is there anybody using the enterprise version of those? So whether it's Ansible or some kind of OpenStack distro or, okay, a couple.
Work for a customer who's leading in the e-discovery space, and their platform was completely based on the Microsoft suite once upon a time. And you can see their product platform mature, and at this point they're talking about their big Microsoft databases, and they say, hey, our customers are telling us that they don't want to pay for the Microsoft licensing to host this database platform. Really big database platform, tons of cores, tons of memory, really expensive. And not only that, they want the enterprise features of that platform as well in the really big ways that they're running it. What we see from that organization is that because the customers want a cheaper solution, they're pressed to look for, okay, how can we manage this with other platforms, right? And they're looking at integrating stuff like Cassandra and stuff like that into their platform and are doing that, and they're pushing that out to customers. So whether or not their customers realize it or not, they're already starting to get on the open source train. I think we'll continue in the enterprise to see that trickle-down effect, but in my largest enterprise customers, we still see a lot of people who are wanting to leverage supported platforms in a lot of ways, especially for the mission-critical sort of thing. So I think it's going to be a while before we fully integrate in that way.
Yeah, and just to piggyback that, I think Josh's point of like tiers of open source and not thinking of a weekend beer project of us being the same as like the work coming out of Netflix that they open source and share of how they run their infrastructure. Different tiers, right?
Totally.
But I found something really interesting that there is a chunk of open source that all follows the Red Hat model, that it's made freely available by people, but then it's picked up and supported in production by other companies. And that's really a sign I look for before I consider something like anywhere close to, quote unquote, enterprise ready and open source is, can you pay somebody to support it? Because if you can't, then it's a lot of risk.
Yeah, if I hit a bug in production on a Tuesday afternoon, can I pick up the phone and get an answer as soon as possible? That's what I need.
In a major manufacturing company like we are, where we're 24/7, we have bottling runs running all the time. The biggest thing is, who can we call?
Yeah.
And do we have a support contract with these people? And yes, we'll embrace this type of new technology, but there's that comfort level at the C level suite where we need to be able to call somebody who can fix this, and there needs to be just as deep pockets as we have to make sure that if they need more resources, that they can bring more resources to the table for that. Because your margin for any kind of disruption in something like that is really, really slim. We looked at one time a company that did a great little app for something that one of our logistics company wanted to do, and researched the company and found out it was 3 guys in a garage in Costa Rica. It was a great little app, but you roll in our lawyers who are like, okay, here's the terms and stuff, and we need you guys to sign this, and they're like, no, we don't, it's not even worth it for them. So that becomes our kind of line of demarcation is, number one, do they have a legal team? Will they talk to a legal team? Do they have people that are there? Are they a structured company? So we have to sit there and dig down into, what's the likelihood that if something blows up, that we have someone that we can go to for help.
Yeah, that's why I think you shouldn't fork Kubernetes and say, I'm going to go to production with it. You should look at the companies that are turning it into a service that you can leverage, like DS, for example.
Yeah, that's definitely where I see the growth, is those companies and the people that are getting together and doing that as a service. Yeah. Cloud apps. Native cloud apps has become a buzzword. What's your guys' take on that?
Lord.
You want to start down there this time?
Okay. I guess that's sort of an ambiguous term a little bit, right? There's lots of ways that something can be a cloud app, especially if you're talking to like an IBM, right? They have a different definition of what a cloud app. But I think just to level set, we're probably talking about a microservices-based architecture, probably starting out in some kind of public cloud platform. I mean, it's become a very good tool to architect your app in that fashion, to take teams to work on their different pieces and be able to push that up into source and run it and scale it as high or low as you need. Now, it's great to think about, but when you first start out and you look at Pokemon Go, right? They're like, we're going to go on Google and we're going to go ahead and we have this microservices architecture. Well, they obviously didn't think it through to the scale that they needed because they didn't think they were going to hit it. So I think definitely whenever you're going to talk building a cloud native app, especially if you expect massive scale, testing is very important. And also an exercise in fiscal discovery is very important, especially if you're talking about an off-prem, like a public cloud provider, AWS. So you need to take and look at something like, okay, we think we're going to scale to X number of instances or X petabytes or gigabytes or terabytes of storage, and then probably double that just to see, okay, well, if we go out that far, what is it going to look like? So I think there's definitely a lot to think about, and it's not just swipe your credit card in AWS and just go. if you're playing around, it's great, but if you're trying to build something that you're going to sell for people to consume, there's a lot to think about.
Yeah, architecture matters so much. I mean, how many of you have seen an app that goes, hey, look, let's take this thing that we used to be able to install here, we install it up there in the cloud, now we're a cloud app, right? Doesn't handle failover, it doesn't deal with any of the magic that the cloud provides for availability, for scalability. You end up with a monolithic system out there instead of right here, and you've just made the situation worse. And it's a very, very interesting conundrum for them. Because what do? Do you stop and re-architect everything? It's probably not in their corporate interest. If you're an upstart, yeah, you can design for that now, and life is good. But we deal with a lot of big monolithic platforms that they think they're cloud ready, and I just kind of chuckle.
Yeah. Retrofitting legacy apps is a nightmare. And then even if you say, okay, well, we're just going to build or buy or have someone else develop for you, there's still, you're dragging along a lot of stuff with you that you have to figure out. So we're pulling in a lot more of our customers these days to have the conversations about what are you trying to do. When you talk about Pokemon Go, we have a marketing team that likes to dream up of these weird, crazy, sweepstakes thing, and we want to put it on. We want a mobile app, and we want to put it out here. And like, well, what happens if it does go viral and if it does go big? Well, we'll just keep throwing AWS at it, or we'll do this and we'll do that. I'm like, at one point, are you going to be paying more than the value that you're getting it from? So then you have to look at it from the business decision. And I think you really have to sit down with your business teams when they look at these things and say, let's look at it holistically. Let's not just sit here and go, yeah, the technology's there, we can do it. Because the technology can bite you in the ass, and then you have someone that's like, you went over your budget, or do you even know what your budget is? Do you even care what your budget is? And they're like, well, I thought it was free, it's cloud. I'm like, no, it's not how it works.
Wish we were all like Netflix, who has 700,000 lines in their AWS bill. I don't know if you guys saw this, but recently Adrian tweeted that picture from one of the Netflix meetups that just showed the obfuscated lines, but no one had time at Netflix to go through each line item because their AWS bill is that long. It's 700,000 lines long. So when I hear cloud native apps, going back to your question, it's still apps. It's just independent of the infrastructure underneath it. In the past, we built it for a static environment. The changes were less frequent. So it was just easy to build a monolithic app, one gigantic app, and deploy it. And it's kind of like rack it and forget it. But we're not in that generation of IT now. It's continuous changes, the whole CI/CD thing of we have to push an update every week or every other week. It's changing, and the cloud that you're deploying it on is different from the cloud you're testing it on. And also, Pokemon Go, the scale. I mean, that's just one classic example, but it's the scale that you need to think through. Are you planning for scale? Can your infrastructure hold that kind of handle that kind of scale? So when you're planning for a DR, do you have the backup? Do you have the other instances? Like if my bare metal fails, do I have a public cloud environment that can handle the overflow of the traffic? Is my infrastructure, like coming from a load balancing company, can my load balancer intelligently divert traffic from this bare metal environment to the public cloud environment? And when I hit that budget limit in a public cloud environment, can it bring it back because now the traffic has come down? So it bottles down to what infrastructure you're deploying apps on and how you're planning for scale. So when we plan for a multi-cloud or hybrid cloud type of deployment, obviously we have to also think of cloud native apps. And when we're thinking of cloud native apps, it's easier to break it into tinier chunks because we now have faster updates to the application. So it's just microservices, much better, way to deploy the applications.
You really hit on a point that made it stick for me, that it's not just about getting version 1 out there. The cloud native architecture has a question of what happens when we have a V2. So does that mean we're offline for 10 minutes, for an hour, for a day? Or does that mean that I just update this one part of a service and the load balancer will just redirect it to the new one once it's up there? And I think it's the shift right from that downtime to there's something smart in the way that will redirect me. Now that doesn't make the bottlenecks disappear. There's still data that we have to store that needs to stay still sometimes. And the other thing I'm really concerned about is that that will often lead to a lowest common denominator architecture, where you're not using all the new speeds and feeds of each server or each cloud platform because you're so concerned about interoperability. So I think a big part of understanding cloud native is understanding how do we find the right orchestrator, the right scheduler system that's smart enough to know where I should go next, where I should push something to, and what it can use there that will be unique for that workload. I think about an example, we're playing with a POC at Intel called Stackinettes, running OpenStack on top of Kubernetes, which, yes, sounds crazy, but stick with me for a second. The one thing that really made sense to me as a demo was the authentication service is really chatty in OpenStack. So it becomes the very first bottleneck when you have users using it. So the Stackinettes configuration, you have the Keystone, the authentication service, set up in this way where you can scale it out. And we'll just spin up a dozen more instances of it. And Kubernetes has a load balancer built in, so it'll just start moving traffic. So based on how many people are trying to log in at some time and their response rate, you could actually automatically scale up that one portion of OpenStack and make it run faster so that people have a better user experience. But getting down to the specifics, that is one stateless part of the overall OpenStack. So I wouldn't say OpenStack itself is ready to roll, but it's a good example of how that one portion of the architecture is designed to be cloud native.
Well, and the platform really starts to matter at this point when you're talking about cloud native apps, because if you think about if you're building a new app from scratch and you've made the decision, we're going to go to AWS. Well, now you need to take into account, well, how are you going to do that? Are you going to use something like a Pivotal Cloud Foundry to build your app on top of, so it might be easier to move to another platform? Or are you going to use AWS's built-in services like Lambda and EC2 and ELB and those things? Because you got to think about the future, right? If you're going to do that, if you decide you're going to standardize on all Amazon services and not use some kind of platform as a service like OpenShift or Cloud Foundry, well, what happens at 18 months, or even in month one when you get the bill and it's $250,000 and you expected it to be $75,000? So you really got to think about the ease of exit for a particular platform from an infrastructure perspective, because it's going to matter.
Yeah.
Conversely, I've been watching this for years. People want to build applications and tools that are cross DBMS generic. And what they end up doing is basically building a system that works on any of these platforms that is the absolute worst performing that they could possibly build for every platform, because they want it to be generic. So it's understand where you want to go, keep it generic if you can, but leverage, when applicable, some of the core specifics of whatever platform you're on, knowing that if you need to switch platforms, you're going to have to rebuild key components there, but that the benefits of doing that are great.
Yeah.
One of our edicts that has come down as another part of our culture change is not to be afraid of failure. Yeah. It's the whole fail fast thing. But in the past, that's why it took 2 years to roll out an application, because it had to be perfect on day one. And if it wasn't, if there was a bug or it didn't work really fast, that means you start all over again. And now it's just know when to cut bait. But don't be afraid to, okay, it didn't work well on this platform, or we didn't use this particular component of it. Okay, well then let's shift. We don't have to wait, 2 months into the development. If we sense something is going wrong or going south, 2 weeks in, 3 weeks in, let's make a change then. Let's not just hold on to it just because it's somebody's pet project.
There's a great quote. I was at LinuxCon last week, and somebody was talking about the Facebook infrastructure, and they said the new Facebook mantra, instead of move fast and break things, was move fast with stable infrastructure. So I think there's a tiered aspect of this, again, similar to our open source conversation, where you can break things, but just break the things that aren't as
Break the
important.
little things.
It's graceful handling.
Yeah, so we do run some things, like if you have a SQL database that's keeping your entire company afloat, don't screw around with it. Work with the right people.
Yeah.
I run some services that do some synchronization between different API sets on our system. So GitHub syncing with Jira for ticket management. It's just a crappy little app that I can go mess around with, and if it doesn't work for a day, no one's going to cry. A lot of people in our field of infrastructure have those type of things that they need to run. Go build it in a serverless way and push it to Lambda, or pop it in a container and run it on your laptop, and figure it out. There's room for those things, and realizing that there are different levels of breakage.
We do that. We tier our apps, and there's apps that are like tier 1 that are do not touch, do not break, and then you have lower apps that when you look at, if there was an outage, could this business survive 3 hours, 4 hours, 2 days? We only use this app once a month at the close of business for whatever crazy. We have thousands of apps. So when you look at that, it's like, well, yeah, you can play around with that. As long as we have a good backup, we can recover faster. But then you get into stuff that's, running furnaces. You need to be very careful, and we are very careful. So we have those standards out there. So that
And you will eventually re-architect all levels of those, but they'll go in different paces.
They'll move up, down, yeah.
Then you break stuff at a higher level.
And understanding the platform is really, really important as well. I had an opportunity to meet a company at Support Tech Field Day, which is really, really an interesting company. They want to do kind of a hosted cloud platform for you, but still allow you to run your infrastructure on-prem. And one of the things that they said was when they started the company, they started it in AWS because they wanted to fail fast. But then they took a look at their bills and they realized, wow, we can do this way cheaper if we do it ourselves. And they actually took all of that stuff that's going to host the platform and they moved it on-prem. It's knowing when to take advantage of the appropriate features of the cloud that you're actually going to use, where you're going to gain advantages, right? So if your app can't handle auto-scaling of some kind, right, it's not the best candidate likely for a cloud platform. It's going to cost you more money, right? So it's knowing when to take advantage of those new sorts of constructs.
So at the end of the day, use the new age IT, but don't blow up my bill.
Yeah.
Yep.
Yeah.
Fair.
Yeah, as we kind of close up here, any final thoughts on the new age of IT?
Sure, yeah. I like to break down, the thing I focused on the most is that how do you become a developer, quote unquote. I'd say you all already are one if you're interested in tech. Just figure out what the different spot you are. Like if you don't know the CLI, work on CLI first. If you then want to get into coding, don't start right with coding, play with GitHub. Because if you can understand Git, you can understand the whole ecosystem of open source code. And then work your way up those layers. And thankfully, I've been working with the vBrownbag team for years now, building an archive of Git tutorials. So if you don't know Git yet, that's probably the place you should start. It's a really good place to be.
Yeah, it's a great project called Commitments. You work on it every year. It's awesome. Check it out. It's links from vBrownbag's website. Everyone should be a part of that. Follow the tutorials. If you have questions, this guy still answers them. It's crazy.
Yeah,
It's crazy.
you bet.
Yeah, mine is always, it's keeping up with change. New age IT changes a lot, but it's an evolutionary change. It moves as fast as you can move or your business can move. Question is, how fast can you keep up? What pieces are inefficient? What pieces need to change? What's coming up that can actually make life a lot better soon, and work to get there. And if you don't, other people will. So.
My key takeaway is go learn something new. We're all in the room, and we're all in this room because we love VMware technologies. I encourage everybody to go just pick a public cloud provider. Start learning a little bit about that public cloud provider. Start understanding what makes that public cloud provider different than what you're doing on-prem so that you can have those intelligent conversations with your management down the road saying, no, we shouldn't do it for this reason. This is actually a really key area that could impact our business as a whole. You need to be that thought leader within your organization, and because you're here and because you want to learn, we already know that you are.
Mine is a parting thought. It's easy to get overwhelmed with the new age IT. There's so many new tools, so many new languages, so many new technologies available. So pick one thing at a time, and in your company, if you're an end user, pick one thing that you want to change at a time. Don't change everything all at once. Pick one thing, the lowest, probably the least affecting one. If you have hundreds of applications, pick the one that you can play with the most and start with it. And if you're a vendor, then like for the rest of us vendors, then please give the tools that are easy to deploy for the customers. Make it developer friendly, especially with going along Matt's advice. Pick something that is easy to use. So pick something that is easy for your customer to use.
I'd say just following what Tim was saying about learning something, sort of a more focused thing is go check out like the Internet of Things, which some people say is the internet, which it's not really the internet to me, but AWS has a great service cleverly named AWS IoT. So you can do any testing. It's very simple to get started. They got great tutorials. I think in the next really 5+ years, we're going to see that thing take off. So it's going to be very relevant.
Great. Well, thank you guys very much.
Yeah, thank you.
Cool. Thanks.
Thank you.
Great. Thank you.